Okay, here are the review problems for our final exam. I printed out the ones that he had just posted, and so now we're going to go through and solve them. So this first one is an EOQ question. A service garage uses 120 boxes of cleaning cloths a year. The boxes cost $6 each. Ordering cost is $3, and holding cost is 10% of purchase cost per unit on an annual basis. First, we need to find the economic order quantity, but before all that, let's find what our parameters are. So we know that D is this 120 boxes, and then we know that S, which is going to be our ordering cost, is $3. H is going to be a little different to find than we've normally done before, but it's not going to be too difficult because we have everything we need. It's 10% of the purchase cost. Well, we have the purchase cost, $6 each. So it's just going to be our percentage times our purchase cost, or or it's going to be 6 times 10%, and that's going to give us 60 cents. Then we can go ahead and plug it into our formula, where Q is going to equal the square root of 2 times ds all over h. From there, we just plug things in. It's going to be 2 times 120 times 3 all over 60 cents. That's what we found here for h. Then we can solve, and that's going to give us 34.64, or if we round it, it's going to be 35. I don't exactly know if he's going to have us round it, but either way, we'll know which one it is on the final, because it's multiple choice. You know what I mean? Next up, we're finding the average inventory from part A. This is going to be half of the order quantity for the average. So this one's going to be Q divided by 2, which is 34.64 divided by 2, equals 17.32 boxes. Again, going forward, I'm not going to be rounding. If it needs to be rounded, I'm sure it will say, or we'll be able to deduct from our multiple choice answers. C is the number of orders per year from part A. This is going to be our annual demand divided by our order quantity. So 120 divided by 34.64 means 3.46 orders per year. Now the total cost, excluding purchase cost, using the order size from part A. Excluding purchase cost means there's one formula that's going to include annual holding cost plus annual ordering cost. That purchase cost would then say plus P times D, so we're excluding that. So our annual holding cost is Q divided by 2 times H, and then our annual ordering cost is D divided by Q times S. We can go ahead and plug everything in here, and we're going to get 10.39 plus 10.39 equals 20.78. Now, something to help with this one is the minimum price is going to be where they're both equal. The EOQ, or the best price, is where these two items are equal, and that's how we know that we're kind of on the right track here. Now, if we were rounding this, they might be slightly off, but they should still be close enough. Now we move on to our next question. The housekeeping department of a motel uses approximately 400 washcloths per day. The actual amount tends to vary with the number of customers who stay on any given night. So that means we're going to have a mean. A mean because it's varying. Usage can be approximated by a normal distribution. That has a mean of 400 and a standard deviation of 9 washcloths per day. A linen supply company reliably delivers towels and washcloths with a lead time of 3 days. That means our lead time is constant because they're telling us it's reliable and it's always going to be 3 days. If it's to maintain a stock at risk of 2%, they give us Z. What's the minimum number of washcloths that must be on hand at reorder time, and how much can be considered safety stock? So that means we're going to have our demand varies and lead time is constant. We're going to look at the different cases. I don't have that in front of me, but if you go back to our slides, it will show 4 different cases that are going to show different ones. Some say both vary, some say only one, and so on. Either way, it's always expected demand plus safety stock. It's just, the numbers that would differ. So first, we're going to have our parameters. The mean demand is 400. Our standard deviation is 9. Our lead time is 3, and our z-score is 2.05. So now we've found our cases. It's case 2, and then this is what case 2 happens to be. The mean of D times lead time plus Z times standard deviation times the square root of LT, and we just need to plug things in. Now you see this little plus sign? It's the same thing. So this is expected demand. This is safety stock, and that's going to come in a second. So we can go ahead and just plug everything in, that 400 times 3 plus 2.05 times 9 times the square root of 3. And when we plug everything in, it's going to give us 1,231.97, or we can round it. That's going to be our reorder point. Now our safety stock is the second half of this problem. It's going to be that 31.97 or rounded to 32. Next, we're going to go on to our stepper problem. I don't know what the right term is. First, we need 50 steppers shipped in week 5 and week 8. We need to determine the material requirements for item E. First off, let's go ahead and make our little production ladder. Is that the right term? Anyways, we have our stepper, and that's going to use 1 of A, 3 of B, and 2 of C. Well, 1 of A is going to use 1 of D and 1 of F. Because we're trying to find E, we can kind of ignore this here. Then we need to have 1 of E for B, 3 of F for B, 2 of D for C, and 3 of E for C. So now we can go ahead and move on, and we're going to go kind of down that line. We don't need this one, so we're going to focus here. First off, we have our steppers. We need 50 in week 5 and 50 in week 8. Now we can go ahead and look on what we have on hand. We can see we have 40 of them on hand. So we have 40. Well, 50 minus 40 means we need to have 10. Now, what's our lead time? To make sure we order those 10 on time, it's 2 weeks. So to have those by week 5, we need to have them ordered in week 3. Now this other 50, we need to go ahead and order all 50 in week 6 because there was none on hand here. That's considering for our lead time. Now we can move on to part B. These are going to match up. It's going to come in later for part C too, but for part B, we have 10 that are needed in week 3. How did we get this 30? Well, we need 3B for 1 stepper. So 3B times 10 is going to give us 30. And then we can do that same thing with that next one. I'll do that in a second though. On-hand inventory is 30, meaning this first half we don't need to order anything. But then we use them all, so we'll have to order all of them later. This 150 comes from the 50 steppers needed times 3B are needed to get 150. And then we look at our lead time, 2 weeks, so then we need 150 need to be ordered in week 4. Now we're moving on to part C. We're using these still to get these numbers. So in week 3, we need 2C per stepper. If we need 10 steppers, that's 20. And then same thing, if we needed all 50 times 2 each, that's 100. Now on hand, we had 30. So that means we don't need to order any here. However, we had 10 still, because obviously 20 minus 30, we have 10 on hand still. 100 minus 10 means we need to order 90. So then we have to go ahead and look at our lead time. And in this case, it is 3 weeks. So 1, 2, 3, we have to order them in week 3. Now part E, don't forget to include both B and C here. Initially, I got thrown off because I didn't do that. So make sure we have both the pieces we need. So first off, I'm going to go ahead and do, hold on. This one is going to be for part C, sorry. So we have 90 that are needed, and we need 3E per. So 90 times 3 is going to give us 270. Next up, it's this 150 of B. We only need 1 E per, so that's simpler math. That's going to be 150. 0 are on hand, so we need to order all of them. In week 3, we need all 270, and in week 4, we need all 150. Then we can go ahead and backtrack with our lead time. So for this 270, 2 weeks, we need to order in week 1, and this one we need to order in week 2. Here's a quick view of everything if you need it broken down and to see everything fully. And then here is our last problem. We're trying to find the critical path. Now this is going to be a little bit counterintuitive, and that's because we are actually trying to find the longest path, because this is the path that's going to take us the shortest amount of time. So we can go ahead and draw it out here. So activity 1 to 2 is 6 months, 1 to 3 would be 7, and so on and so forth. Now we can look at our different paths that's going to get us from 1 to 5. Path A is 1 to 2, 2 to 5 would take 13 months. And path B is going to be 1 to 3, 3 to 4, 4 to 5, which would take us 22 months. So that means our path is going to be, path B is our critical path, and our normal project duration would take 22 months. But now they're saying they want to reduce it by 3 months. So we're going to have to crash here. That's what it's called. So we're going to focus on our critical path because reducing it of the other one isn't going to really affect it. We want to focus on our critical path. That's why we're doing 1 to 3, 3 to 4, and 4 to 5, like here. So first we need to calculate the max time reduction. So that's going to be our crash cost minus our normal cost, all over our normal time minus our crash time. So this first one's going to be our 3,500 minus 3,000, all of it's given up here, and then 7 minus 5. That's going to give us 500 divided by 2 is 250. Now keep these in mind because that's how many months can be taken off from that one piece. In this case, it's 2. So we go ahead and continue and do that math for the other ones. And once we find that, we're always going to crash the lowest per month. So first off, we're going to look. Our lowest is right here, $200 per month, and that's going to be by crashing 4 to 5. Meaning we're going to make it 9 months, it's going to become 8. So instead it's going to cost us $200 a month, now it's taking us 8 months. So now that's $200 we just spent to make things go a little faster. So our first one is still 7 plus 6, but now it's taking 8 months. Our next lowest is going to be right here because this only had 1 month. See? Now 1 to 3, $250. So now we're going to lower it by another month. That's going to cost $250, and that's going to make our path 1 to 3. Instead of 7 months, it's 6. So 6 plus 8 is 20 months. We're still trying to take it off by 1 more month. Our next lowest is still going to be this 1 to 3 because it can reduce it from 2 months total versus just 1. See, and we know that because this was a 9 to 8 and this one's 7 to 5. So we have another month we can use there. So now we reduced it by 1 more month, or it's going to be 2 months total, however you prefer to do that. And that's going to be 5 plus 6 plus 8 is 19, is our new 19 months. That's our new critical path, but that's our new shortest time. We just crashed it and took off 3 months. It went from our 22 months to 19, but we did spend another $250. Now we need to add these up, which is going to be 200 plus 250 plus 250, and that means $700 is our least cost of reducing the project completion. So to make it that 22 months to now 19 months, we had to spend some more money to reduce these times. Now, for this to make a little more sense, say they said reduce it by 4 months. We already used 1, 2, 3 months. Now we would go to our next least expensive, which would be 300. Hopefully that all makes sense.